My area of expertise is our VMware Identity Manager, as well as ThinApp, because I came with the acquisition of Thinstall. But lately I've started to focus on our access point product as well. So today's topic is actually not about any of those products. The idea was to present you with a walkthrough of the industry standards when it comes to authorization and authentication protocols. So this slide deck, typically when I present this, it's a 4-hour session. So there's quite some depth in the original deck. This is obviously stripped down a little bit, but I kept certain slides in there, not with the intention that I would have time to go through it, but since I will share this deck, I hope you'll find it interesting and you can walk it through yourself. All slides, more or less, have very detailed speaker notes. So the idea is that it can be used as self-educational as well. Anyone here in the identity access management business? Somewhat? No? You all have heard of these standards, have you? Everyone? I will walk them through and point out where their different use cases are and how they work, how they function on a fairly high level, but still explain the different functionality of the different protocols. So, but first we need to agree on what is actually identity management, or I should refer to it as identity management and access management. Typically, identity management mostly focuses around the life cycle of the user object. You create the user, you delete the user, you provide user access to different systems, you provision the user into different systems as such. Access management, which is in the business where we are playing within VMware with our Identity Manager product, which should have been called Access Management product, but that's the way it is. It's the notion of providing correct access to the correct user. I provide proof of who I am, and then I get access to the resources that I should have. So that is basically the general idea of managing identity and access. First, very, very basic. There is two main differences when we talk about access management. One is identifying yourself. That is referred to as authentication, often shortened as auth-n. And then, for example, you provide your username and password. Hopefully you haven't shared the password with anyone, so you are who you claim to be. Authorization is the other thing we need to be aware of. This is the notion of providing access to something once I have proven I am who I claim to be, often shortened as auth-ced. So when you, for example, have authenticated, providing your username and password, and you try to access a file share, now you're using your authorization to access those folders and files. When we started to develop software, we had the software engineer or the developer focusing on the application, the business value that the application provides. But pretty soon it became obvious that we need to separate different users from each other. Could be that the user has different user preferences. Perhaps I would like to have a different background color than my colleague. Then the developer needs to know who is actually using the system right now. Could be different level of authorization. So perhaps I can see my salary statement, but I cannot see my colleagues, obviously. So pretty soon the developers had to start to create these logic, which is actually separate. It's not core of the application itself. The application is providing some kind of business logic most of the time. But before I can start to deliver that business logic, I have to take care about the authentication and the authorization. becomes even worse if I have multiple different applications. And especially as a developer, if I have created a logic for users to type in username and password, I'm now responsible for making sure that that logic is secure, so no one can circumvent that. I need to store my user data in a secured fashion. So quite a bit of code that I need to create that is actually outside of my main interest. So this is very painful for the developer. For the end user's point of view, the end users need to sign in to different systems using different username and passwords. So the users aren't happy, neither are the admin, because the admin, if a user leaves the company, the administrator has to go in each application and revoke access. So today, in the modern world, we are working with something that is referred to as the claim-based model. So the application trusts a third-party entity, often referred to as the identity provider. If this identity provider claims with the help of a token, or we refer to them as actual claims, if the IDP says this is Peter Björk accessing, then the application trusts this and allow access for the end user. The benefit of this is that the logic, the authentication logic, is now gone. It's a much, much simpler logic that simply accepts claims. And if you as an enterprise now would like to support not only username and password, but Kerberos and some other standards, it's up to the identity provider to sort that out, not the developer. The developer's application remains untouched. Now the logic of a user database and authorization is optional. You could very well provide a claim that specifies I am a HR person. Then I would have access to certain features within the application. But most likely, the authorization and a local user database is still maintained by the application. If we now deploy multiple applications, we can still use the same IDP as our trusted entity, and the IDP will automatically provide claims on the behalf of the user. So the user, first of all, the developers is super happy. They are not responsible if someone managed to hack the authentication logic. The users is super happy because they only have to log in once to the IDP. And then for the IT admin, if the IT admin disables a user here, obviously the user cannot access any of the applications. So this is a much better system instead of relying on individual applications logic. Often when we talk about access and access management, we talk about something referred to as the realm or the security domain. So this is within your company, for example. All your client trusts your identity provider, and your application trusts this identity provider. But if you start to work together with many different organizations, or you do a merger, obviously there is no trust by default. But you can look at the realm just like you looked at the application in previous example. A whole organization's network or realm security domain can be federated. So I can trust other domain, security domains, identity provider. And now if a user is created in realm B, it's up for the realm B administrator to take care of disabling this user if the user leaves the company. If they want access to realm A, the realm A admin just need to create the trust between the two realms. So a much, much simpler way of federating users between different security domains. Very, very high level, just to set the scene. So next topic is SAML, and SAML is by far the most popular standard or protocol used today for federation. This protocol can be used for many different things. It's actually quite modular and quite flexible. It can be used for both authentication and authorization. Let's look at the different parties in the SAML trust. So first of all, we have the user, which is often referred to as the user agent, which tends to be a web browser. It doesn't have to be a web browser, but many times you will use a web browser or web SDK components to communicate with your SAML applications and identity providers. The identity provider, as in my previous examples, is referred to as identity provider. Why I listed here is because all the other standards obviously made up their own names for the identity provider. And then we have the service provider. The service provider is actually the application. The application trusts the identity provider. And when the user authenticates into the identity provider, requests a resource, the service provider in this case, a SAML assertion is generated and passed somehow to the application. We will cover a couple of different methods of passing the SAML assertion over to the application. Within this SAML assertion, it's XML-based. You'll find statements about this user. All statements are considered true because this assertion is signed, sometimes encrypted, by the IDP. When you establish the trust, you exchange certificates. So we trust anything that is signed by the identity provider, we know should be true. At least we trust it to be true. So within this SAML assertion, we have things like user attributes, username, email address. We can put anything pretty much in the SAML assertion. It also identifies if the user actually managed to authenticate, which method it authenticated. My service provider here may trust the identity provider, but may require a strong authentication method in order to gain access to the application. So even though I successfully authenticated, I may only get access to a subset functionality until I actually get a claim proving that I used a multi-factor authentication method. And then the session starts between the application and the end user. So I mentioned how can we pass, or in this case, how do we initiate this flow? There is two different methods, the identity provider initiated and the SP initiated. So IDP init, the flow looks something like this. The user agent starts by accessing the identity provider. I want access to a portal that is a part of the identity provider, for example. The identity provider challenged the user to authenticate, obviously. User authenticates successfully. Now the user requests a service or an entitlement. The identity provider generates this SAML assertion, and in a redirect message via the web browser, the SP, the service provider, receives this SAML assertion. And now the session can start. At no point does the service provider has to communicate with the identity provider. The user agent, the web browser, the client itself, must be able to communicate with both of them. But we are using the browser, this is often referred to as passive flow as well. The web browser is passively forward, back and forth. It doesn't really take an active part of the authentication logic. We have the other method, which is SP initiated. So let's say you are an Office 365 customer. You go to the portal of Office 365 first. So you try to access the application. The application recognizes that you are not authenticated yet, so it redirects you to the identity provider. Authentication happens, but now the user doesn't have to choose the service. The service provider, in the redirect message, identified itself. So the identity provider already knows what I'm trying to access. So it immediately creates a SAML assertion. The same kind of redirect message happens, and the user gets access to the service provider. We have a special version of handling or passing the SAML assertion, which is referred to as the artifact method. In this case, I'm using the SP init flow, but it can just as easily be the IDP init. So the user starts trying to access the application, gets redirected, authentication happens. So far, identical as all the other examples. Now, the identity provider generates two messages. One is a very, very small artifact that is just an URI, a redirect URI with an unique identifier at the end. And this URI is redirected to the service provider. Now the service provider takes this artifact and requests the full SAML assertion from the identity provider. At this, and obviously the session starts. In this case, we require communication on the backend between the service provider and the identity provider. Some claim or look upon this as more secure, because the actual SAML assertion is passed many times on the backend in the data center. So I would say not using artifact is still quite secure. SAML is the de facto standard of using federation. But if you want to add some extra security, perhaps artifact would be of interest. Again, your application and identity provider must support this, obviously. So it all depends on what is possible as well. Just to tie this to our products, for example, Horizon, our VDI solution, supports SAML, but requires artifact. But the Horizon client cannot support the SAML assertion. So the Horizon client receives this URI, connects to the connection server pulls the SAML artifact. This case is a little wrong when we talk about Horizon, because Horizon doesn't support SP init, so it has to be an IDP init workflow, but still. So the benefits is the artifact is so small that pretty much any client can cope with it. It's just a it's just a row of URI and a URL. The downside, obviously, is it does require this backend connectivity. For you who are, there is tons to discuss when it comes to SAML troubleshooting, but my favorite tool, if you're not aware of it, is SAML Tracer, which you can download and install to your Firefox. And if you hit an IDP and connect to an SP, it will clearly identify messages that are SAML. And then you can investigate those. And this is a typical SAML assertion. And here, for example, it may be fairly small for you, but here you can see the username, valid time, period. SAML is very, very time critical because it has only a very short period of time when the SAML assertion is actually valid. So if you have time drift within your system and try to do SAML, it won't work. And then, in this case, what method of authentication was used. But there is much, much more information in the SAML assertion there. So, WS. WS is not one standard. WS is, I wouldn't say hundreds of standards, but it's a quite decent list of standards. The most interesting and the ones that we tend to refer to is WS-Fed. But WS-Fed is just a portion of what is used by Office 365, for example. So I will not dive too deep into WS. You will see why in a second. I just wanted to mention the different parties. It's also 3 different parties. The requester is the end user. Security token service is the IDP. And then you have a resource provider or relying party, which is the SP in SAML lingo. So why do we care about WS-Fed? There is one reason, but it's two-folded. IBM and Microsoft invented it. That's the only reason we care about WS, because Microsoft requires WS for some of their implementations, especially when it comes to Office 365. Older software applications for Office doesn't support anything but WS. I'm being told, I haven't tried it, but Microsoft said they would start to support native SAML eventually with the newer versions. And then perhaps WS will fade away. I didn't want to go too deep into WS. I think, in all honesty, SAML is absolutely good enough when it comes to federating. What is much more interesting is the, so to speak, newer protocols. One of those is the OAuth 2 protocol. Many have heard about OAuth 2, but it seems to, when I'm in a dialogue with customers, there is some confusement about what actually OAuth 2 does. OAuth 2 is not an authentication protocol. It's not an authorization protocol either, but sort of. It's for delegating. Typically, you could have an application that you as a user authorize or delegate access on your behalf to. So hopefully it will become clearer eventually. OAuth 2 is very popular because it's what tends to be used, especially with native mobile applications. Especially if you have a web portal aggregating information from other web applications, OAuth 2 is probably being used in the background. The use case, as I mentioned, is to delegate access to a third party on your behalf. What is the benefit of using a protocol instead of simply providing your username and password for Dropbox, for example? Well, if you establish this trust to your native application and your backend, Dropbox in this case, the authentication or the security is handled by the OAuth token. So I can now, in Dropbox, change my username probably not, but my password. It wouldn't break the connectivity for my native application. So it frees up and allows user for much more freely change passwords. And the user in all these web applications in Dropbox, you can see which OAuth tokens are now active. Which applications has access to my account, and I can revoke access for individual applications. So if I lose a device, I can simply go in and see Peter's MacBook revoke access. And I know this native application now cannot authenticate without me actually typing in my username and password. It's also one side effect of this, or built into the standard, is that if you grant access to an application to another application, you are never ever providing your username and password. When authentication happens, the user are redirected to the original web application, and you authenticate yourself there, which makes the user a little more comfortable because they recognize the page and everything. With OAuth 2, you and the application and the backend negotiate a scope. The scope means what level of access can this application, or do I allow this application to have on my behalf? Typically, you should be able to modify the scope. But in most integrations or implementations, the scope is required. You can simply approve or deny. But in the standards, it should be possible for you to actually say, no, only read my public profile, my username. You have not access to my contacts, for example. But this is a screenshot from a typical OAuth Scope negotiation. So New York Times here would like to have permissions to the following. Do you allow or do you not allow? The parties, when it comes to OAuth 2, We have the resource owner, that's me. I know my username and password. I have a client, an authorization server, and a resource server. In this case, I have a natively installed mobile application. The native application, when I launch it, tries to access the backend. I'm not authenticated, so the resource server redirects me to my configured IDP. This is separate from OAuth 2. This has nothing to do with OAuth 2, so it may be a different server or anything. But somehow, the user successfully authenticates. Now we need to agree on a scope. Do I allow the native mobile version of Salesforce to access Salesforce on my behalf? Yes. Two tokens is passed. This is customizable. The access token is a requirement, but the refresh token is optional. The access token is used to gain access to the service. The refresh token, as the name sounds, allows the application to request a new access token without actually prompting the user for a username and password again. They both obviously have different time to live, and most of the time you can configure this on the back end. But there is another use case also. You have two web applications running on two different companies' offerings. So in this case, let's say the web application A is this portal that aggregate information from many different web sources. So this could be my bank web page, for example, web server, the application B. What has to be done first is that the admin of web app A registers on application B. And then application B generates a client identifier and security. This is used by application A to at all communicate with web server B. The resource owner, the user, now visit the web application and wants to add content from the other web application. The web application reaches out and says, hey, could I please add content for this user? Obviously, you cannot read this, but it says no OAuth token. A OAuth token needs to be created, so a redirect message happens all the way to the original web application. As mentioned before, at no point in an OAuth flow will, in this case, application A, be able to get my username and password. So I'm redirected to the original website to perform authentication. I agree on the scope. An authorization code is passed back to the application. This authorization code is used to reach out to the application B, to receive the access token. So now, even though the user is not logged in, application A can retrieve information from application B. And then obviously, data can pass. 10 more minutes. So next topic is the OpenID Connect, which is picking up quite a bit in popularity, especially since it started out as a protocol used mostly in the consumer space. But it's definitely finding its way into the enterprise and quite rapidly as well. But OpenID originates from OAuth 2. They are not compatible, but they use the same notion of access token and such. OpenID Connect is much, much more strict when it comes to what is allowed and what is possible, where OAuth 2 is very flexible. The tokens can be pretty much anything that you pass to between these systems. So the different parties is you have an OpenID provider or an AS, a relying party or the client. When the application tries to gain access, so OpenID Connect is used for authentication. where OAuth 2 is not. So the user is trying to access in SAML lingo, the service provider, the application. The user is redirected for authentication. The user authenticates. Access code is redirected, very similar to the SAML artifact workflow. And now the relying party can use this access code to retrieve the access token. And what is new with OpenID Connect is that we also receive an ID token. And this ID token identifies the user. The ID token, the system can read. So I can read the username, email. The access token, I cannot do anything but providing it as a key to gain even more information about this user. And when I've received all the information that I want, the session can be established. So what is in an ID token? Typically, if you compare to SAML, which can contain pretty much anything, every attribute that you can think of, the ID token only contains a very, very few attributes. And then you use the access token to retrieve more information about the user. But the whole flow, like this, is very, very similar to SAML artifact. The backends needs to be able to communicate with each other. The last protocol that I wanted to cover, if time permits, I have a very quick flow about NTLM, but Kerberos is the most important protocol, I would say. Kerberos is actually my personal favorite. It's extremely intelligently invented, I would say. The whole idea is how can we more efficiently authenticate a user without passing the password and provide mutual authentication. So the server actually authenticates back to the user to prove that the server is actually the server I tried to connect to. Kerberos is not a Microsoft invention. It was invented by MIT. Microsoft started to use it, though, to replace NTLM. But you find Kerberos support in Mac OS, Linux, in iOS devices, natively supports Kerberos. So don't make the mistake to think that the second we start to talk about Kerberos, we immediately mean Microsoft networks. That is far from true. The protocol is used mainly for authentication. Yes, so why is it called Kerberos? Well, obviously for the three-headed dog. So we have three parties as well in this protocol. We have the client, we have the resource, and a KDC, the key distribution center. And obviously, in Microsoft world, this is your Active Directory domain controller. It's the client who drives, that means 5 minutes, okay. It's the client who drives the authentication. So the client connects to the KDC, the client connects to the resource. At no point in time during the authentication is the resource reaching out to the KDC to validate anything. The KDC knows your secret. When you join the domain, you share your secret with the KDC. So the KDC database is extremely important. Obviously, you would protect it with everything you have. So there, in a Kerberos realm, there is only two parties who knows one and the same secret: the client and the KDC, or the resource and the KDC. And this is where Kerberos is to my, what I think is very geniusly created. The basics I will simply walk through. Then I have, I think, 10 slides with very, very detailed animations. And I can tell you, it took me a couple weeks to build the animations. So if you download this deck, which will be shared with you, and you are interested, you can walk through and see exactly what happens in each step. I will just give you a short taste for it. But the principles of Kerberos is the KDC can generate a message encrypted with the client's secret, pass it over to the client, and obviously the client can decrypt it because the client knows its own secret. But the client cannot generate a message encrypted with its own secret and then pass it over to the resource, because the resource would not be able to read it. The resource doesn't know the client's secret. So what KDC does instead, or the Kerberos standard does instead, is every time the client wants to communicate with the resource, the KDC creates two messages. One encrypted with a client secret, one encrypted with a resource secret, and pass both messages to the client. I, as a client, can read my message that is encrypted with my secret. I cannot do anything with the other message, but I can forward it to the resource. And now the resource can decrypt it. And this is used to prove that I have validated myself against the KDC. The KDC vouches for me by encrypt a message stating my username in a message that I cannot manipulate. So the resource decrypts the message, sees my name, and says, yes, you are Peter Björk. So just to give you a flavor on the kind of animations that I spent weeks on doing. So it's very, very detailed. And the whole purpose is to explain this flow. This is actually the correct Kerberos flow. Sorry. There you go. So, just to finish it up, because I only have 1 more minute, there is 2 main differences in how a client authenticates in Kerberos. You provide your username and password, or you can use a certificate. The certificate method is referred to as PKInit authentication. So, there is a couple more slides here with some details, a quick walkthrough of the pros and cons, NTLM versus Kerberos, and how NTLM actually works. And here is a ton of information if you're interested in reading up more on the different protocol standards. And again, this slide deck will be shared with you. And if you have any further questions or are interested in a much, much deeper session, please let me know. I put my Twitter alias up here eventually. There you go, the PEB. So if you need anything, please reach out to me. I'm more than happy to help you.